Here we go with another Math is Everywhere topic of the day. We're talking about systems of equations and how to solve them. Here's one more method you can use to solve a system of equations. It's called the elimination method. So we talked about graphing, we talked about using the substitution method. Now we're going to do the elimination method. And you'll see why it's called the elimination method in just a second. So in the last video on the substitution method, we talked about this problem. There's two numbers. We don't know what the two numbers are, but the sum of the two numbers is 40, and their difference is 4. So find the two numbers. Well, if the sum of the two numbers is 40, that means they add up to 40. We'll call the two mystery numbers x and y. And whatever those two mystery numbers are, their difference is 4. That means when you subtract one from the other, you get 4. So how do we find those two numbers? Well, we could graph both these equations and see where the lines intersect. We could use the substitution method, but what we're going to use today is something called the elimination method. And when we use the elimination method, what we try to do is we try to take the two equations and line them up one right underneath the other. And this works really well when both equations have like terms lined up so that the x's are stacked up and the y's are stacked up, and then the just plain number parts are stacked up. It works really well when we have it like that. So watch what we can do when we do have our like terms all lined up. We can basically just take this whole thing and we can add this way. X plus x is 2x. And then add this way, and then add this way. But what happens when you do y plus negative y is, 1y plus negative 1y actually cancels the y's out. And do you see why it's called the elimination method? Yes, because we just eliminated the y's. What do we have left? Well, just 2x on the left side and 40 plus 4 on the other side. And watch how easy this is to solve. You just divide both sides by 2, and you get x equals 22. And we're halfway done with this problem. Now, to solve this problem, we know we have to have the y part. So how do you find the y part? Well, you take the 22, you plug it in for x, and we're going to do like a substitution thing here. So 22 plus y equals 40, and now you just subtract 22 from both sides, and you get y equals 18. And so now we have the solution to our system of equations, 22 comma 18, or x is 22 and y is 18. And the whole thing happened when we took our system of equations and we lined up the x's, lined up the y's, and lined up the other parts. And then what did we do? We just added, and figured out what the equation is that we have left. Okay, so we're going to try that again. So in case that example didn't exactly work for you, we'll try another example. What if you have x plus y equals 17 and y equals 2x plus 2? Well, when you try to line these up, the elimination doesn't really work very good for a problem like this, because did the like terms line up with each other? Not really. X and y aren't like terms. Y and 2x aren't like terms. So we wouldn't probably use the elimination method for a problem like this. All right, but for a problem like this, it might work because, oh yeah, look, the x's and the y's line up. So let's see what we get. We're going to, if we add and add and add on this one, we're going to get 9x, and y plus y is 2y, and 10 plus 8 is 18. Wait a second, I thought this was called the elimination method. Something was supposed to get eliminated, but we didn't eliminate the y's or the x's. There's still a y there and there's still an x there. So you know what we're going to do? Instead of adding and adding and adding, we're going to subtract. So watch what happens when you subtract each time. So we're going to take this whole equation and we're going to subtract Now what we'll get when we line this up is 5x minus 4x gives us 1x. And y minus y gives us nothing. There's our elimination that we were looking for. And then 10 minus 8 gives us 2. Everybody see how we did 5x minus 4x gives us 1x, y minus y gives us nothing, and 10 minus 8 gives us 2. So now that we have that, we actually solved for x, because if 1x equals 2, that means x equals 2. And we know half of our solution is x equals 2, right? What's the other half of our solution? That's where we're going to plug the 2 in for x, right there. So we're going to do 5 times 2 instead of 5 times x plus y equals 10. And we know what 5 times 2 is. It's 10. 10 plus y equals 10. Oh, y must be nothing. Y must be 0 if 10 plus y equals 10. And now we've solved our whole system of equations, and we have a solution. Okay, so that was the elimination method. And sometimes we subtract and subtract and subtract, and sometimes we add each time. It just depends on what the two equations look like. All right, let's try another example. If you have x plus 2y equals 10 and 3x plus 4y equals 8, what's going to happen here is if you add here, that's not going to eliminate anything. You're going to get 4x. And if you add here, that's not going to eliminate anything. You're going to get 6y. But if you subtract here, that would be like 1x minus 3x, which is negative 2x. And if you subtract here, that would be like 2y minus 4y, which would be negative 2y. That didn't eliminate anything either. So does the elimination method always work? Not always perfectly easily, but guess what? There's a trick we can do on this. We can take this whole first equation, and since nothing eliminates yet, we can make something eliminate. So what we really want is, instead of an x and a 3x, we want a 3x and a 3x. Or instead of a 2y and a 4y, we want a 4y and a 4y. So what we're going to do is we're either going to try to make these x's match or try to make these y's match. So I'm going to multiply this whole top equation by 3, and watch what I get. 3x plus 6y now, because I distributed this 3 here, and I distributed the 3 there, and then I'm going to have to distribute the 3 here, equals 30. And now what I can do is I can take this equation and I can subtract it. So I'm going to do 3x minus 3x, right, minus 4y, and then minus 8. And what I'm going to get here is 3x minus 3x cancels out. There's my elimination that I wanted. And then 6y minus 4y is 2y, and 30 minus 8 is going to give me 22. And now I can just finish solving this by dividing both sides by 2. Those cancel, and I get y equals 11. Now, am I done? No, I only have the y part. I need to get the x part here, and I can do that, of course, by just plugging something in. I can plug this in right there, because I know y is 11, so now I know that x plus 2 times 11 equals 10, and I can just solve this equation. This is 22, and now I'm going to subtract 22 from both sides, and then this will scratch out, and I'll get x equals 10 minus 22, which is negative 12, and so now I know my solution to the whole system of equations is x equals negative 12, y equals 11. Okay, so sometimes in order to do the elimination method, you've got to take an entire equation and multiply it by 3. Or multiply it by some other number. Okay, I'm going to do a really fast new version of this same problem. Okay, and I'm not going to try to confuse you here. So if you're getting confused, just ignore what I'm about to say. You could also, instead of multiplying this by 3, you could also have multiplied this whole thing by 2. Because watch what happens when you do that. You go 2x, and you go 2 times 2y is 4y, and then you do 2 times 10 is 20. And that might not seem like it helps until we see that we can subtract this whole equation. And so we're going to go minus 3x, and we're going to go minus 4y. Now we see what's going to eliminate, and we're going to do minus 8. And so what we're going to get here is 2x minus 3x is negative 1x, and 4y minus 4y, that's our elimination. That's what we were looking for. So we did eliminate something, and now we get negative 1x equals 12, and I'm just going to divide by negative 1 so that those scratch. Divide by negative 1, and we'll get x equals negative 12. Okay, and of course we would have to continue and solve for y, but what I'm trying to show you here is we could have made a match with these two to make an elimination, or we could have made a match with those two to make an elimination. Either way gives us the elimination we're looking for in the grand elimination method. So that is what we call the elimination method. Here's a practice problem for you to use, and this one's on the simpler side. And I think what you can do is either add, and get a new equation down here, or you could subtract, and get a new equation. See which one gives you an elimination and helps you solve for x or y. If you're confused, just ask me some questions tomorrow in class and we'll work on it together. Thanks for your time, thanks for your patience, thanks for all of your hard work in making sense of these problems and persevering in solving them. Here's another practice problem. If you want to give that a try, go ahead and try it. Go for it. If you think that looks too scary, don't worry about it. We'll talk about it in class tomorrow. All right, that's all I got for you. Sorry this video is so long. Have a great day.